So first, I'm going to make an observation that backend developers don't ship, and I will explain what I mean by that. Then I will show you a few examples of PHP console applications, so existing ones. Then we'll go through some tools, so the tools which are available out there to build console applications, but also more specifically the tools that we are going to use today. Then I'll go through the concrete steps to build a console application with PHP. And then I will sort of conclude by asking the question why. Why would we do that in the first place? And finally, the last slide is just a reference to the tutorial which I've published and on which this presentation is based. So should you wish to explore the topic further and actually build something after this talk, which I hope you will be able to refer to that tutorial. Okay, so backend developers don't ship. So what do I mean by that? So basically, as backend developers, we don't tend to build and ship products A to Z. And the reason for that is because we would need to know the whole stack, which is more or less represented on this burger, which you may have seen before. So on this full stack burger, PHP developers are here. Now, we're all different. We all have different profiles. Some people will be full stack developers, so meaning they will know about the backend, but also about the front end. Some people like me are more focused on the backend, so they will also know a thing or two about like the API layer or the database layer, sometimes the infrastructure layer as well. So we all have different profiles, different like strengths and weaknesses. But apparently we've got something in common, is that we know PHP. And the good news is that by just knowing PHP, you already know enough to build and ship products A to Z, but for the console. Okay, so before I give a few examples of PHP console applications, can anyone think of any examples off the top of their head? No? Cron job? Yeah, okay, so that's more like general. It's not like a specific console application. But is anyone on macOS? Anyone using Valet, maybe? Okay, so Valet is a PHP console application. Oh, yeah, okay. Okay, so here's a list of examples. You might recognize some of them. Actually, do anyone use any of those already? No? Yeah? So yeah, a lot of them are static analysis tools. I'm not going to explain what they are. That's not really the point. But then again, if you are not familiar with these tools, I invite you to look them up after the talk, because I'm sure we'll find something that you will want to use. But the point is that PHP console applications are already very much a thing, and there are some quite popular ones out there already. Okay, so the tools. So first you've got the frameworks. You've got the minimalist frameworks, which is the case of Minikly, which is a framework to build console applications with PHP, which doesn't have any dependency out of the box. You've got bigger frameworks, which is the case of Laravel 0, which, as the name indicates, is based on Laravel. So it's basically like a stripped-down version of Laravel. And you've got frameworks more focused on the appearance of the application, like the style, which is the case of Termwind. Nuno Maduro, who is the creator of Termwind, who is also the creator of Laravel 0, by the way. Nuno Maduro describes Termwind as Tailwind CSS, but for PHP console applications. So I know there are some full stack developers in the room, so maybe that gives you an idea of what it is. If you're not a full stack developer, don't ask me, because I've got no clue. But that's it for the frameworks, and we are not going to use any of these tools today. No. The first tool we are going to use is Symphony's console component, and that's going to be to build the application. The console component is essentially a library, which allows developer to interact with the console, quite simply. It's a library which is quite popular, and it's used by some major frameworks, so chiefly Symphony, but also Laravel. So I don't know if there are any Laravel developers here, but Laravel has this component called Artisan, which is like the console component of Laravel. Well, Artisan is built on top of the Symfony's console component. So yeah, a very popular library, very reliable, battle-tested. So it makes sense to use it as a starting point for our own console applications. The second tool we are going to use is PHP Unit. A very popular test framework for PHP, and that's going to be to test the compatibility of our application with a range of dependency versions, but I will get back to that. The third tool we are going to use is GitHub. That's going to be to host our code and also to perform some continuous integration, but I will get back to that as well. And finally, the last tool we are going to use is Composer, so the dependency manager of PHP, and Packagist, which is like the main repository for Composer. And that's going to be to distribute our application. So something you might notice already is that most of these tools are probably familiar already. There is nothing too exotic in there. Okay, the steps. So first, I'm going to show you what we are going to build today, the example application. Then I will go through the prerequisites. Then the first concrete step will be to create a repository and to install the core dependency of the application. Then we will talk about the entry point of the application. Then the command, which will contain like the mechanics of the application. Then we will see how we can style the output a little bit. And then we'll see how to check that our application is compatible with a range of dependency versions. And finally, we will see how we can release and distribute the application. So just so you know, I am not going to go into too much detail for each of these steps, because my goal today is really to give you a sense of what it takes to build a console application with PHP. But then again, on the last slide, there will be a reference to a tutorial on which this presentation is based. So if you want to go ahead and build something and have more details, you'll be able to refer to this tutorial. Okay, so this is what we are building today. So it's a game. It's a game of sums, very simple. So the game asks the player some questions. The player can give an answer. The answer is either right or wrong. And every time the player gives an answer, the game asks if the player wants to play again. And that's it. Very simple. Okay, the prerequisites. So you are going to need a GitHub account, but a free one will do. It's more than enough. You will also need a Packagist account, so it's free as well, only takes a few seconds to open, so you basically need an email and a password, and you're good to go. You will need a local PHP install, a local Composer install, and a terminal to interact with the above. Then again, nothing too exotic in there. Actually, I think most of you probably have all of that already, if not maybe a Packagist account. Okay, so the first concrete step is to create the GitHub repository. It can be public or private, that's up to you. The only thing you need to know is that later, upon submitting the package to Packagist, the repository will need to be public at this stage. So here I created mine, I called it PHP CLI demo. And once you've done that, you clone the repository locally, so with git clone. So Hostil is my nickname on GitHub, and so it's also my vendor name, just so you know. Once you've done that, you run composer init, which is a command that initializes a new composer project. And it's a command that asks you a series of questions about the project, so stuff like the name of the project, a description, who the author is, that sort of stuff. And once you're done, it will generate a composer.json file for you containing all of the information that you've provided. Once you've done that, you can install the core dependency of the application, which is the Symphony console component, like I said earlier. And once you've done all of that, this is the file structure you should get. So the directory of the application, the PHP demo, the vendor directory, which contains the composer dependencies, and then the composer.json and composer.log files. So far, it is pretty standard. Okay, so the entry point of the application. So the entry point is a file which basically receives like the input coming from the console. It's a little bit like the index.php of our console application. And we call this file a binary. So here I called mine demo. I put it in a new directory which I called bin. It doesn't have to be in this directory. It could be at the root as well. That's up to you. I just like to have my binaries in the bin directory. And this is what it looks like. I'm gonna break it down now because this file is quite interesting. So first you've got that first line there, which is basically what tells the system which executable it should use to run the file. So essentially here we are telling the system, hey, you should use PHP to run this file. And this is also what will allow us later on to when we want to invoke our application, we'll be able to just type demo in a terminal without having to specify PHP beforehand. Okay, and then what we are doing here is we are looking for this file, autoload.php. So this file is generated by Composer, and this is what will allow us to import and use the Composer dependencies in our application. Typically, if you're using a framework like Symphony or Laravel, the framework does that for you under the hood already. But what's interesting here is that we are looking for this file in two different places. Why is that? So the reason is because we can use our application in two different contexts. The first context is the current context. It's like the development context. So we've created the repository, we cloned it locally, and we are going to work on our application, right? In this context, this is what the file structure looks like. So the demo file is here, and we are trying to get to the autoload.php file, which is here. And basically, we are trying to get to the directory which contains the vendor folder, because it's the vendor folder that contains the autoload.php file. Meaning, we are here in the demo file, and we need to go one level up to find the PHP demo folder, which is exactly what we are doing here. Because the name is a PHP function, which gives you the parent directory of the directory you pass as an argument. Here, as an argument, we pass dir, which is a predefined PHP constant, which gives you the current directory. So essentially, this line means, give me the parent directory of the current directory. When we hear the current directory is bin, the parent directory of the current directory is PHP demo, and that's indeed the directory that we want. Okay, so that's for the first context. The second context is when you've distributed your application and someone installs it globally on their computer, right? It's like the production mode, if you will. In that case, this is the file structure that you get. So the folder represented with a tilde symbol here is basically the user directory. And in that directory, you've got the .composer directory, which itself contains the vendor folder, which is where all of the globally installed composer dependencies are. Then you've got the autoload.php file, and then you've got all of the globally installed dependencies. So they are filed by vendor name. So here is mine, hostile, and then you've got the application folder with the regular file structure. Okay, so in that context, the demo file is here, and we are trying to get to the .composer folder here, because that's the folder that contains the vendor folder. Meaning we need to go 1, 2, 3, 4 levels up, which is exactly what we are doing here. Because the dir name function accepts a second argument, which is the number of levels up you want to go. All right, so with those like 5 lines there, we basically cover the two contexts in which we can use the application. Meaning from there, we can safely load the autoload.php file, And what's left to do is to instantiate our application and to register the commands of our application. Here, there's only one command, the play command. It doesn't exist yet. We're going to create it on the next slide. So instantiate the application, register the play command, and then run the application. And that's it for this file. This, by the way, was the most complicated slide of the presentation. So if you survive this one, you will definitely be okay. But that's not all for the entry point, actually, because in order for Composer to know that it's a binary file, we need to tell Composer that it is a binary file. And we do that by updating composer.json, and we need to add this section to it. So this is basically telling Composer, hey, this is a binary file. And what that does really is that once you install the application globally on your computer, for instance, Composer will sort of promote this file as a globally available executable. This is basically what will allow us to then, in the terminal from anywhere, to type demo, and that will reach our application. And the last thing we need to do is to make sure that this file is actually executable, which is how you do it with chmod plus X. Okay. Okay, so let's talk about the command. So like I said, the command is the class which will contain the mechanics of the game. So in order to create it, I've created a new src folder here, which is where Composer expects to find your source code by default. Remember a few slides back, we ran the composer init command, which asks a series of questions. One of the questions is where the source code will be. And the answer by default is src. So unless you specify the different folder at the time, you need to create the src folder. That's also for PS for autoload mapping. In it, I've created a new commands folder, which will also be the namespace for our commands, as we will see, and then the file for the command play.php. Okay, so this is the command. I'm going to break it down now. So the first part of the command, so first you've got the namespace, so starts with the vendor name, then you've got the name of the application, and then commands, which matches the directory that I've just created. Then you've got the dependencies of the class. So we are going to extend the base Symphony command, and then we will interact with the base classes of the input and the output as well. And we will use the Symphony style class, which is a helper class, which I'm going to explain in a bit. So like I said, we extend the base Symphony command, and here we define a name and a description for the command. The name and the description will appear in the menu of the application. And the name is also used to invoke the command. So basically, typing demo will display the menu of the application, and then typing demo play, we actually start the game. Okay, that's it for the first part. And the second part of the class, so it's made of the execute method. So this method is expected to be implemented by the parent class. So if you don't implement it, the parent class is going to throw an exception. It receives an instance of the input and the output. And like I said, it's the bit that contains the mechanics of the game. So remember, it's a game of sums. So we prepare the terms here. We pre-calculate the result of the sum. And here I instantiate the Symphony style class. So like I said, this is a helper class. And basically what this class does is it gives you a bunch of base elements for your console applications. So that's stuff like titles and sections and tables, progress bars, this kind of stuff. And it also exposes a few methods to help you interact with the end user of the application. So here, for instance, we ask a question, we collect the answer in this variable. Here we make sure that the answer is equal to the actual result. If that is the case, we display a success message, and if it's not the case, we display an error message. We can ask the player if they want to play again with the confirm method. which is different from the ask method because it expects a Boolean answer, so essentially yes or no. And if the player wants to play again, we just call the execute method recursively. Okay, last thing to note about this method is that it's expected to return an integer. The reason for that is because by convention, console applications are expected to return an integer, indicating whether the execution went well or not. So here I return a constant, which is provided by the parent class as well, success, which equals 0. The reason is because by convention, again, when the execution went well, the application returns 0. If something went wrong, we usually return 1, and if something was invalid, so if the input of the command was invalid, for instance, we return 2. Okay. So at this stage, we can test our game already. The first thing we can do is to display the menu of the application. So remember, this is the development mode. And in that context, this is how you can interact with your binary, so ./bin/demo. This is the default menu of Symphony console applications. And if you look down there, we can see that we've got the name and the description that we've specified on the previous slide. As for the game, this is what it looks like by default, which I think is not too bad already, right? But then again, so it's a game, so like those messages like OK and error, they're a bit dry, right? And maybe we could add some emojis here and there as well, just to make it a bit more like user-friendly, right? So let's see how we can do that. Okay. So in order to style the output, what I'm going to do is I'm going to extend the Symphony style class. To do that, I've created a new services folder here. It doesn't have to be named services. It could be named like whatever you like, helpers, for instance. And I've named my class input output. I guess I wasn't super inspired on this one. And this is what it looks like. So, like I said, I extend the Symphony style class. And basically what I've done here is I've created methods which kind of reflect the needs of the game. So we are asking questions, and the answer can be right or wrong. I didn't change the confirm method because I thought it looked good enough already. For the question method, I'm just calling the parent ask method, but what I'm doing is that I'm prepending this sort of writing emoji. And for the right and wrong methods, I took inspiration from the success and error methods. So I saw that they were calling the block method. So I'm doing exactly the same thing, but I got rid of these OK and error messages here, and instead I'm prepending some nicer emojis there. And that's it. So now we can update our command to use this class instead of the previous one. So very briefly, on top, we import the new class. We instantiate it instead of Symphony style, and we use the new methods. Once we've done that, we can test our game again. And this is what it looks like now, which I think is much better. And that's it, by the way, because this is the final design. This is essentially the design I showed you at the beginning of this section. Which brings us to dependency version support. Okay, so what we're doing here basically is to, we allow other people to install our application globally on their computer. But that bears a couple of questions. The first question is, what if they have a different PHP version than ours? And the second question is, what if there is already another PHP console application on their computer using the same dependency as us, but a different version, potentially an older version? Because we've got no way of knowing that, right? So the best we can do is to make sure that our application is compatible with a range of PHP and dependency versions. And the way to do that, the first thing we need to do is to update composer.json to list the versions with which our application is compatible. So what I've done here, I've just added support for PHP 7.4 here, and for Symphony console 5.0 here. Okay. Once I've done that, how do I actually make sure that my application is compatible with those versions, right? I could do that manually. I could essentially change the PHP version on my computer manually and start the game and play the game and make sure that it doesn't crash. I could do that. I could do that, but it's a bit of a pain, right? It's not very practical. So instead of doing that, I am going to write some unit tests. And I'm going to use PHP Unit for that. So I need to install it as a development dependency. So composer required --dev. And then I'm going to create a test class for the play command. So I created a new test folder there, a commands folder which reflects the structure of the src folder. And init the class to test the play command, so playtest.php. And this is what the class looks like. It's very small. There's only one test. Test, it does not crash. And what I'm doing in it is I instantiate the play command. And I use this class, command tester, which is provided by Symphony as well, which is another helper class, which basically provides a test environment for my commands. And it allows me to do stuff like simulating a series of input, which is exactly what I'm doing here with the setInput method. So this is basically like me answering 10, yes, 10, and no in a console. So 10 would be the answer to the first question. Yes, I want to play again. 10 would be the answer to the second question, and then no, I don't want to play anymore. And I execute the sequence. And then here, I'm just making sure that the command is successful. So basically that it returns 0. I don't actually care if the answers are right or wrong, because this is not what I'm interested in here. I just really want to know that the application runs successfully and doesn't crash, essentially. But then again, if you build something of your own, you might want to have some tests which will test the actual behavior of the application. But then again, that's not what we are interested in here. Okay, so once I've done that, but it's already a little bit better because I still need to change the PHP version manually. But then instead of testing the game manually, I can just run the test. And this way I can know if my application is compatible with this new version of PHP. But changing the PHP version manually can still be a bit of a pain depending on your setup, right? So we are going to automate that bit as well. And the way we are going to do that is by using a Github Workflow. And we are going to use a Github Workflow to run the test on a matrix of PHP versions, which is almost as cool as it sounds. Has anyone used Github Workflows before, by the way? You have? Yeah? Cool. Well, even if you haven't, you will see that it's not that bad. Okay, so I need to create that workflow. So to do that, I create a new .github folder, a workflows folder in it, and then my workflow. This is a GitHub convention, by the way. This is basically where GitHub expects to find the workflows. And my workflow ci.yaml, because indeed it is a YAML file. Here it is. So at the top there, you've got the name, CI stands for continuous integration. And then you've got the conditions on which the workflow should trigger. So here, anytime we push some new code to the main branch, or anytime we open a pull request towards the main branch. Then we define the jobs of the workflow. Here there's only one, because the only thing we want to do is to run the test suite. So I called it PHP Unit. I want it to run on the latest Ubuntu, which is pretty standard. Then I define a strategy for the job, which is where I can specify the matrix of PHP versions I want to use. So here I specified PHP 7.4, 8.0, and 8.1. And what that means is that the steps here are going to be run for each of these PHP versions. So then you've got the steps of the job. So the first, we need to check out the code of our application. Then we need to set up PHP, which is where we specify, we tell it to use the current PHP version. We don't need any test coverage here, so I set none. Then we install the composer dependencies, and finally we run the test suite. So for those unfamiliar with GitHub Workflows, every time you see the use keyword here, it means we are using GitHub Action. GitHub Actions are like some like building blocks for your workflows, if you will. This one is very standard. It's all over the place. Everyone uses it. And the PHP one, Setup PHP and Composer Install are quite popular as well in the PHP ecosystem. And then again, I invite you to look them up if you're not familiar with those. They're quite useful. Okay. Once you've done that, so you save the file, you commit the file, you push the file. And then on the GitHub repository, you've got these Actions tab. So you click on that, and after a few seconds, this is what you should see. What that means is that the job was run for each of these PHP versions, and each time it was successful. And that's pretty much it for the dependency version support. Essentially, we've just proven that our application is compatible with these PHP versions. So what that means is that every time you push some new code to the repository, or every time you open a pull request towards the main branch, the workflow will trigger and immediately tell you if your changes are compatible with all of the versions you've listed in composer.json, which I think is pretty cool. Which brings us to the last step, which is the release. So still on GitHub, in the bottom right corner of the repository, you've got this release section. So if you click on that, it will take you to a page where you will be able to create a new release, which is this form. You need to specify a tag and a name for the release. So I went for v1.0. You can specify a description as well. You click publish, and you've created a release. Once you've done that, you need to head over to packages.org. So then again, if you don't have an account, create one. And once you are logged in, there is this submit button in the top right corner, which will take you to a page where you can submit your package, which is essentially the URL of your repository. And this is the moment when your repository needs to be public, because if it's private, packages won't be able to see it. So you submit your package, you wait for a few seconds, and then this page should appear. And if you take a closer look in the bottom right corner, you will see that the release that we've just created is listed there. And that's it. You've officially released your application. From there, if you want to install your application globally, you use Composer Global Require and the name of your application. And then if everything went well, from anywhere in the terminal, you should be able to type demo play, and that should start the game. If you release a minor version, say 1.1, the way to get it is to run by running Composer Global Update and the name of your application. And if you release a major version, say 2.0, you would need to run Composer Global Require again. And that's it for the concrete steps of building a console application with PHP. Now, it's all well and good, but at this stage, you might be wondering, okay, but why would we do that? Why would we bother creating console application with PHP? Well, there are a few reasons for that. And the first one is that it can be useful to you. I'm sure you can think of like a task, something you do regularly on your computer, which could be automated, but which doesn't necessarily require like a full-fledged website, right? It could be anything. I'll give you an example. So I'm using this website called Readwise, which is essentially an application which allows you to import your book highlights. So, if you're like reading something on your Kindle, there's a passage you like, you can highlight that and save it for later, right? So this application allows you to import those highlights, and what it does is that every day it sends you an email with a selection of those highlights, like a randomized. So the goal is for you to retain the information more easily, right? So I use this application, but the issue is that it's not compatible with my brand of reader. Well, actually, it wasn't compatible. It is now, but at the time it wasn't, because I've got a Kobo. And what I needed to do then was to take my Kobo, export my highlights as a weirdly formatted text file, convert that text file to a CSV file, which would be recognized by Readwise. And that conversion from the text file to the CSV file was a proper pain. So what did I do? I created a console application to do that. Very simple, just takes the text file as an input and spits out the CSV file as an output. Quite simple, but saves me a lot of time. Right. So there you have it. That's one example, but could be anything. Could be something to help you with your taxes, for instance. I don't know. I'm sure you can think of something. Another reason, it's a way to showcase your work. So back to my initial point of being a backend developer. As a backend developer, it's not always easy to show our work, right? We don't exactly have portfolios. So what you could do instead, you could create a console application and put some effort into it, and then you could show that instead, right? Other reason could be a way to learn some new skills, quite simply. Like I don't know if everyone is comfortable with unit testing or with continuous integrations, for instance, which we talked about today. So that could be a way to get started, for instance. Other reason, the process is actually quite similar to that of developing a library. So I don't know if any one of you has done that before, but if you wanted to create a package for Laravel, for instance, well, the process is quite similar. Like, for instance, you will probably want your package to be compatible with different PHP versions and different Laravel versions, for instance, right? So essentially, once you've done that for a console application, well, you're actually pretty much ready for some open source work, which could be interesting. And finally, it's fun. Yay! You know, you could just like build something for yourself using a language you already know and love. There's no front-end work. There's barely any styling. There's no server to maintain. Like none of that stuff. All you need to know is PHP, and you already do. So let's build. As promised, this is the link to the tutorial on which this presentation is based. So then again, it covers everything we've seen today, but in much more detail. So really, if there's like one slide to save today, it's probably this one. And then again, you can find all of my technical writing on my blog, tech.hostil.me, and you can follow me on Twitter. The handle is @hostil, and I post about backend development, among other things. And that's it.